Good morning, good afternoon. My name is Robert Schmid, also known as Mr. IoT. I am Deloitte's Chief IoT Technologist with a deep passion for all things digital. This week on Coffee with Mr. IoT, I am talking with David McCall from Intel. David, thank you so much for joining. How are you?
Very well, thank you. Thanks for having me.
David, you and I met twice actually at the Zigbee conference. You are really heavily into standards. I have to admit, when it comes to acronyms, you're gonna outdo for sure me, but many others too. Give us a little bit of an intro, all the things you work in, because I know you started with you're in the OCF, but you're on a variety of other forums. Tell us, what is that? And just tell us how that contrasts or compares with your day-to-day job at Intel.
Okay, well, my day-to-day job at Intel right now is as part of the Connected Home division. It's the section of Intel that produces silicon and platforms for telco and cable modems. So it obviously has an interest there in the smart home area. But prior to that, I was part of a innovative team. It's designed to build new solutions in a variety of different areas, but focused on the wireless connectivity. And that was actually where OCF started. So OCF is a standards organization that was put together by Intel, Samsung, and a bunch of other companies back in 2014. This designed to develop a common language for the Internet of Things, solving some of the basic problems of interoperability between IoT devices. So OCF as a standards org has a specification and a certification against that. And also, it's a little bit unusually, has an open source project associated with it as well, which is IoTivity. So that produces a reference implementation for the specification. So that's what my side gig is at the moment, although it's a fairly substantial side gig. I'm actually now president of OCF. So it's been an interesting 4 years, and we haven't got a lot of devices out there right now that are using OCF technology, but we have got over 445 members, including some of the really big players. And at IFA this year, Samsung, Haier, Electrolux, and LG all announced their commitment to shipping all of their appliances using the OCF technology. So we're expecting a big ramp in product shipments in the coming year.
So OCF, first of all, it's an acronym. What does it stand for, number one? And number two, I gotta tell you, I have so much admiration for people like you, because I easily get frustrated when I feel internally we are herding cats and there's a lot of different people we got to bring together. I have no idea how you do this with companies that some of them compete and you have different interests. How do you do that? How do you go about that?
So OCF is the Open Connectivity Foundation. And I think that it's one of the interesting things in the technology industry is that you very often have companies who compete like crazy against each other in one form and then work extremely well together in these industry standards organizations. Now, there is a common complaint that standards work progresses slowly, but it takes time to get 40, 50, 100 or more companies to all agree on the same direction. The reason that people put in that time and effort is that ultimately everybody benefits. There are certain areas that just wouldn't work. I mean, look at Wi-Fi, for example. That's one of the biggest successes in communication technology that everybody's familiar with. Can you imagine what it would be like if every company had their own version of Wi-Fi, none of which were compatible with each other? In fact, you even saw that when they were developing 802.11g and N, that people released pre-G and pre-N products, which they hadn't got the specs fully worked out at that point. And not everything worked well together. And the recommendations from pretty much everybody was just wait until you have got the full certification from the Wi-Fi Alliance going. So this is why people do it, because there are examples where you need products from different companies to be interoperable. This is the way it happens. And so people put in the time and the effort. And it can, sure, for some people, it can take a lot of time and they don't want to put in that effort. But it's also very rewarding at the end of the day to see that if you've been involved in a standard and then it gets adopted just across the world and everybody's using it. I was involved in the early days of Bluetooth and that was deeply satisfying when you see that that Bluetooth logo is popping up on phones and PCs and speakers and headsets, and it's great to be part of something that's that scale.
It's interesting that you mentioned Bluetooth, because I thought of this, how Bluetooth has become so much more than it originally was intended. I mean, with low power Bluetooth, I mean, we're getting so connected, it's not even, it's kind of crazy. So I'm kind of curious, where do you see this go? And I'm particularly curious, where do you see this go in relation to 5G?
Wow. 5G is always one of those topics coming. It's everything to everybody. At the moment, there's so many different technologies being counted as being part of 5G. But look,
But do I need 5G if I have good Bluetooth around me and then Wi-Fi?
I think you probably want it. I mean, it's addressing some definite concerns. I mean, I think that it is by far the most ambitious of the wireless standards that is being worked on at the moment. But the goal that it has is just quite incredible. I mean, just getting so many devices connected over actually what's a range of different technologies, but being able to have some of the reliability and time sensitivity, so you can start doing things like with vehicles, for example, real-time communication of vehicles. You can't rely on a 4G system, on an LTE system for that. It's just not going to cut it. Industrial process control, 4G LTE is not going to cut it. So there are definitely applications where that's going to be very, very important. But I think it's going to take a long time for that to really impact the most consumers in ways that they really appreciate, because they are fundamentally new use cases. It's not just a case of the new thing is faster, which has been the case in the previous iterations of the mobile technology. But what you're seeing just across the board is everything is wanting to work with everything else and integrate, and this is the goal of delivering the Internet of Things. It's really just that everything is getting a little bit smart and a little bit connected, and that is a huge range of devices. And I think people are only really starting to grasp the full implications of that. So what we're seeing, I mean, OCF was partly set up to try and address the issues of fragmentation and drive more interoperability at a higher layer. And we're seeing that general push is something that more and more companies, organizations, and more people are agreeing that has to be done, and that all the organizations are wanting to start working with each other. And I know that I met you at this, an event that was organized by one standards organization, but they were pulling in lots of people from other standards organizations. And I think that's just one really good example of that.
It's interesting, right? Just yesterday, you talked about all things will be connected. I love doing this, all things will be connected, with the mental challenge. What does that mean for you as a company if your product is connected? How does a consumer expect to be treated if it knows you have access to maybe usage patterns or product health and stuff like this? So I think there's a real shift in how particularly product companies will be challenged in terms of connected products. That really fascinates me. But the funny thing was, if I would have said, I always say all things will be connected. And my thing is that I've said yesterday to someone, well, any product over $100 will be connected going forward. And a year ago, they would have argued with me, oh, no, not all things will be connected. Yesterday, the argument was $100. I think it's more like 50.
Yeah. You're buying, the Echo Dot is coming out. It's $25 on offer. That's a very connected device.
I know.
So yeah, absolutely. It is quite incredible.
So I want to ask you something, and I want to switch topics away from standards. By the way, if you're just joining us now, I'm Robert Schmid, the Chief IoT Technologist for Deloitte, and you're watching Coffee with Mr. IoT. Today, I'm talking to David McCall from Intel, and I really appreciate you being here. We talk about standards and Intel and all those good things, and IoT. So I want to switch to a different topic that I believe you're going to have some interesting thoughts on, which is edge and fog computing, right? I think one of the things that fascinates me about IT the most is how, we've had this movement from on-prem to cloud, and I go from down to here, right? I like physically point up. And now I think we're going to bring it back down way closer to people, especially with many, many more connected pieces. We need to have compute power sit right around us. And so for me, that's edge computing. And I love the fog analogy, because what it is lots and lots of little devices and compute power and storage and network connectivity all around me. That's all going to start working together as one. How do you think about this? What do you think? And I'd love to hear what you can say, how you as Intel thinks about this, because you guys got to be super excited about this idea of having lots and lots and lots and lots of little chips around us.
Oh, as long as they're all Intel chips, obviously. But yeah, this is one of the huge potential growth areas for compute, and it's so new though that the terminology isn't really entirely fixed yet. But I think there is an increasing difference being drawn between edge compute and fog compute. So personally, when I think of edge compute, I am thinking of compute that is at the edge of the network, but is an extension of the cloud. So it's very much a sort of a tiny data center that's sitting in your home or in the office, that from the cloud perspective looks very familiar and is mostly controlled by processes that have previously resided in the cloud. So it's the edge coming down a little bit the cloud coming down to the edge, but it's still very much part of that existing cloud architecture, and the edge pieces are still very reliant on having that cloud component. They're putting down the bits that would otherwise run in the cloud, but whether it's due to bandwidth, latency, robustness, security, privacy, or maybe regulatory requirements around some of those last three, that are better done at the edge. And then fog computing is like the next level, where you have a whole array of compute capabilities at the edge, and you can sort of throw a process at it, and each individual node is communicating with each other at a sort of operational level and making decisions about what to run where, and all of that is taking place at the edge. So it's almost more like a multi-core CPU making decisions about what to run on which cores when, but this is now spread out over lots of different compute nodes that are running potentially in different devices. But that whole system is working together, and it isn't quite so reliant on having a cloud component that's making all of those decisions. So these are, I mean, the edge is happening right now. Edge compute is, you're seeing the cloud providers, all of them have their own edge solutions, ways that you can put something on a device at the edge and have it work as part of their cloud using a lot of the same tools. Fog is a little bit further out, but when that actually gets working, it's going to be another like step change in the way that people are dealing with compute.
So I have to tell you, listening to you, to differentiate between edge and fog, I get it, what you're saying. It makes sense to me, but it almost feels a bit arbitrary and to separate the two, because for me, it's everything. Anything is close to me, I consider sort of edge. And now when we separate it even more, it's going to get even more complicated for the end user to figure out, or not the end user, but the architects and the companies to figure out, do I do edge, fog, cloud, on-prem, it's going to be interesting, I think. I don't know. I'd almost like to make a side bet with you here that I think we're going to converge edge and fog into one, and it'll be ambiguous to the developer where they put it. I think they will still choose between cloud and edge, or fog for that matter, but not at that level. But also, I wonder if that has to do a little bit in terms of what tools we get provided by people like you and all the big tech providers that help us with that. But anyhow, I don't know if you want to take that side bet. I'd bet that edge and fog will converge into one. Do you want to take a bet?
I don't think No, I would not take that bet because I don't think it's going to be a clear dividing line. I think though that you can look at some systems and they're going to be very much edge, and you're going to look at some systems that are going to be very much fog, and there's going to be plenty of gray in between where it's a bit
Got
of
it.
one, a bit of the other. But I do think you are going to see what I describe as much more edge type solutions deployed before you reach some of the more fog type capabilities. I see that as being a sort of a little bit further ahead.
So what's Intel? I mean, you shared your view with me on that and how you differentiate. Where do you see what about Intel and what you do with connected home product and so forth? What can you
So,
tell us? I guess is my question, maybe more than anything.
well, we're obviously looking at how the gateway device can be a good edge compute node.
Mhm.
That's obviously part of what we're looking at. But I can't make sort of any specific comments about the product plans. And the other thing is that
Mhm.
when we're working at providing the silicon and the platforms, we are working with the ODMs who make the boxes. We're working with the cable companies and the telco providers. So those are the ones who make the decisions about exactly what the edge gateways are services are going to look like. We just make sure we've got the right silicon, the right platforms to deliver that. So it's very much a partnership there. But it's a box that is in a lot of people's homes already. It's always on. There's a good support model and subscription models associated with it that make it a good candidate for a lot of the smart home services that people are looking to deliver.
I gotta believe with you said it, the silicon and the platform. You gotta be moving more into platforms too, with fog and edge coming along. Is that true?
Well, yeah, and this is one of the things when you're looking at the back to the comment of everything's coming together. If a device is going to be a good edge compute node, then it better work well with the cloud services, and those cloud services exist, separately from what a lot of devices that previously weren't edge compute and now are becoming edge compute. Those were two separate worlds. And now you're saying, okay, I want to run this as an edge compute node. Well, that might mean you have to run a slightly different operating system. It might mean you have to put in some more memory. It might be re-architecting things, so you're using containers or virtual machines in order to provide security. But you're having to see those same problems being solved for all of these different devices. They were previously completely separate ecosystems, but now they all need to work with the cloud, and so the cloud is going to be driving some convergence there. Everything's coming together.
I appreciate that. So let me shift to some topic, and I don't want this to be our last topic, but I want this to be our second last topic. And it's the topic when I get it asked, I'm waiting for it to happen. Where does security and privacy fall for you? We spend a lot of time at this when we talk about standards and so forth, but I just love to have a bit of a riff from you on that. And I know they're two different things, and I think I mentioned them that way too, but sort of like, where do you see people's responsibilities and so forth?
Well, I think that everybody recognizes now that security is a huge topic for the Internet of Things. You're opening up just some really new, the professionals call attack surfaces with IoT. And you're also having devices where people didn't have to worry so much about security. Now they really do have to worry, because every device that's connected, everything's getting connected. Every device is a potential path for an attack. So this is actually get to a lot of the work which we do with OCF. Historically, the way that you handle security best is you have open standards, open source code. You have as many people as possible looking at what's out there in the field, and trying to find the problems with it and fix the problems with it in public. This is all shared, and you're pooling expertise. A lot of the problems arise whenever you have somebody who thinks they know how to do it, and they go off and create their new protocol, or they implement something incorrectly, and then that gets out into the field, and you end up with, the Mirai virus was one of the worst examples there, where people just picked up and used something, didn't fully understand it. They had default passwords, and you ended up with a really horrible situation. So with OCF, we're trying to do that, have the open standards for IoT security, and we've also got the open source code that people can pick up and use really easily. And if there are any issues found, because nothing's perfect, then you can address that very quickly by having a change to the spec, an update to the code, which gets out to as many people as possible really quickly. So it's a big issue. We know the fundamentals of how to deal with it. The challenge, I think, is that right now everybody's trying to move really quickly, and speed isn't necessarily your friend when you're trying to build a secure system. You need to go through the full security review, security lifecycle, and it's an ongoing process as well. It's not just when you ship your product, you're done. Everything is connected now, so you need to be connected and updating those devices. It's a big task. On the privacy side, I think we're really only starting to grapple with that. I do think that the Internet of Things offers some incredible opportunities for services, and the whole idea of having a personal assistant who can help with your life is clearly a valuable thing, because really rich people pay someone to do that for them. They'll pay quite a lot of money for someone to be an actual personal assistant. But it's interesting that with that one, you have a certain assurance of privacy and security, because you're paying that person quite a bit of money, and their livelihood depends on it. With the digital personal assistants, you're going to be, if they're going to be as effective as the person, then they're going to have access to all of that same sort of information, and it could be really bad if that gets into the wrong person's hands. And as I said, it's digital, so there are a lot more attack vectors. So figuring out how to handle that information, how to provide those sorts of services, and get that user's trust, not just pretending, but because it really is secure. Whether that's some combination of holding more private information at the edge, the private information doesn't really leave your home. That might be part of the solution, but it's a big task, and I don't think we've really grasped yet what's going to happen. And I think maybe it's going to take something. This sounds horrible to say it, but maybe it's going to take something like the Mirai virus on a privacy side for people to really grasp what is possible now with the amount of information that's being shared.
I have a way more positive outlook. I think privacy will evolve as we did on phones, and we're going to get much smarter at this as users as well as people who develop apps, but that's just me. I got to ask you for a closing comment. So I want to say thanks for being here. But I want to close by asking someone who works so close to the fastest, most efficient chips that can be made and in connected home groups. What's your favorite piece at home, or how does your home look like? I'm dying to know.
I am curiously something of a late adopter. I'm not an early adopter. Yeah. I play around with this stuff, but here's the thing. I'll be completely straight. I travel a lot, and if something breaks and my wife can't get it fixed again, I'm in trouble. So I need to make sure this stuff needs to be really solid. And we're certainly there's certain components in there. I have to say, look, the thing which has made the biggest difference has been the Echo. And just being able to control a few things around the home with that, but it's actually surprisingly non-fancy, but that's largely because it's got to be 100% solid, and a lot of the really cutting edge stuff, it's great when it works, but there can be problems.
I gotta tell you, yesterday I had my doorbell ring me. My house was totally like couple thousand miles away from where I'm at. I picked up my phone. I talked to the delivery person with the Amazon package, and gosh, they looked at me weird when they heard the voice coming out of the speaker. It was pretty funny. So with that, we're coming to the end of the show. It looks like the coffee break is over. I want to thank you, David, for a great conversation. Thank you so much.
Thank you.
And please join me again next Friday, 9 a.m. Pacific, noon Eastern, for another Coffee with Mr. IoT. And by the way, if you missed any part of today's conversation, you can watch the episode again on my YouTube channel as well as past episodes. And with that, David, thank you so much. Have a great Friday.
Thank you. You too. Bye-bye.